Ah, okay, Mr. Aaron, I'm done with the video.
Another one, another one, another one, and another one.
Oh, alright then, I will do it again. Okay. Hey, so today we're gonna learn about the very fun educational lesson about volcanoes, earthquakes, and tsunamis with case studies. When it was first formed, the Earth was liquid rock, but as it cooled down, the outer surface hardened to become a thin crust. Oh, not that one. A thin crust. Underneath the crust is the mantle, which makes up 82% of the volume of Earth and is 2,900 kilometers thick. Underneath are the extremely hot liquid outer core and the solid inner core, which is in the center.
We found by switching the letters around. So if someday
The Earth's crust is broken up into a number of enormous pieces called plate tectonics. There are 7 major plates, some of them which are larger than the continents. These plates are constantly on the move, rubbing against, crashing into, or moving away from each other. The edges where this happens are known as plate boundaries or margins. Plates are made of 2 types of crust: continental crust, which is light but very strong. It cannot sink and it cannot be destroyed. Oceanic crust, on the other hand, is heavier and sinks under the continental crust. It is continuously being destroyed and replaced. Plates move because they are floating on the extremely hot mantle. The mantle is made of a liquid called magma, and the intense heat coming from the Earth's core gives rise to convection currents. These currents push under the plates and cause them to move. Here is the worldwide distribution of earthquakes and volcanoes, which is near the margins. When 2 plates move away from each other, a constructive margin is formed. Magma rises from the mantle to fill the gap that is created, and this forms a new oceanic crust. Where plates containing oceanic crust moves towards those containing continental crust, a destructive plate boundary is formed. The heavier oceanic crust is forced underneath the continental crust in the area called subduction zone. Friction causes the crust to melt, and newly formed magma may be forced to the surface to form volcano.
Oh, I'm a gummy bear. Yes, I'm a gummy bear.
Where 2 plates slide past each other, no new landscape is formed, and therefore there is no volcanic activity. However, earthquakes can occur at this conservative plate boundary. If the plates get stuck, pressure will build up until it is released, causing the Earth to jerk violently. When 2 continental crusts move together, there's no volcano, no melting, but there is a fault mountain. Tephra, rock fragments and particles released by an eruption. Lahar, fast-flowing river of water, mud, lava due to eruption. Shield volcanoes have gently sloped sides and wide base, and are found at constructive plate boundaries and hot spots. As the plates move apart, lava seeps onto the Earth's surface through cracks. Layers of lava builds up, and the volcano is formed. Eruptions at shield volcano tends to be non-explosive and involve rivers of lava flowing down the volcano. An example of shield volcano is Mauna Loa in Hawaii.
No.
Basic lava forms shield volcano. It is thin and runny because it does not contain much silica. Composite volcanoes are steep-sided and cone-shaped, and they are found at destructive plate boundaries. They are formed when an oceanic plate is forced underneath a continental plate. The end of the oceanic plate melts due to friction and heat from the mantle. Creating extra magma, pressure builds up as more magma is produced and forces its way upwards through the tectonic plates, forming volcanoes. Eruptions at composite volcanoes tend to be violent and explosive, as pressure builds up over many years and is then released in seconds. Acid lava comes from composite volcanoes, which is thick and sticky because it has high silica content. This comes from an oceanic plate that is melted. Volcanic